Hello and welcome to AGN 3613. In this session we will address how annual worth analysis could be applied in calculating the unit cost or unit profit. In addition, we will learn how it could be used to compare the unequal service life projects. Let's start with the unit cost or unit profit calculations. Since we are dealing with units, then we need to know how many units has been produced per year. In addition, we need to identify the cash flow series associated with these units. All cash flows will be returned to point 0 as a present worth of the production line. Knowing the present worth will assist in finding the annual equivalent worth. We divide the annual worth or cost by the number of units per year to get the unit cost. Let's look at the example that we used in previous session. Knowing the cash flows from the diagram and knowing the operating hours per year, let's first bring all cash flows or flow values to the point 0 using the present worth calculation with interest 15%. So we will bring all these values to year 0. And we have that 75,000 at year 0. So we have all these present values. We find the net present worth at 15%, and that will equal $3,553. If we would like to calculate the annual worth, then we use the annual worth formula, which is A given P with 15% and 3 years period. Using that formula, we can get the annual equivalence, which is $1,556. To calculate the savings per machine hour, then we divide the annual equivalence by the number of hours that will be operating, and that will be equal to 0.78 per hour, or 78 cents per hour. 78 cents per hour. The unit cost assists in comparing between the option of making the product in-house or buying the product from an external source. To do that, we need to determine the number of units needed per year. Then we need to determine the cost of the equipment, manpower, and all other resources needed for the make. We also estimate any other cash flows associated with the make option. We can find the present worth, then the annual equivalence for the cash flow. Once we find the annual equivalence, we can divide that by the number of units from that item and get the total unit cost made in-house. We identify a supplier and obtain a quote for the cost of the same number of units if we would like to buy from an outsource or an external source. Then we can compare the two options, the one for the make and the one for the buy, and we take the proper decision based on the analysis or the information that's being gathered from both ways or both methods. When the part made in-house, the company will make sure that they are producing a part that complies to certain design specifications. It will be produced when needed, and there will be no shipping or handling cost that will be associated. It's all internal, which will guarantee that there is no delay also. So whatever being produced, it will be sent to another department that will start the assembly or the production for the second product without any delay. And that's the beauty of having it built in-house. No shipping, no handling, no delays, no nothing. When buying the units from a supplier, the quality of the product and that it complies with the specification have to be considered. You have to make sure that it complies to your specification, up to your standards, and with the good quality that you need. In addition, the reliability of that supplier to produce enough units and deliver them in time have to be considered. If the difference between buying and making is not that much and will guarantee to get a good quality unit, the difference could be ignored and items could be purchased. As we said before, the annual worth could be used to compare two alternatives or two projects. To do that or to understand that, we can look at the example in this slide. We have a company that would like to purchase motor and they are looking at two options. The first option is a standard motor with 25 horsepower, 20 years lifespan, 0 salvage value, and 89.5% efficiency. The cost for that one, if I would like to buy that one, will be $13,000. The second option is a premium efficient motor with 25 horsepower, 20 years lifespan, 0 salvage value, and 93% efficiency. The cost for that one is $15,600. Whether we buy the first or the second, the purchased motor need to operate for 3,120 hours per year, and the energy cost is $0.07 per kilowatt hour. Now with 13% interest, we need to calculate the operating cost for each motor, then compare the options and select the proper motor that need to be used. So we need to calculate the actual input power for each motor first. The input power will equal the out power divided by the efficiency. Based on that, the input power for standard motor will equal to it will be 18.650 kilowatt divided by 0.895 efficiency, and that will be 20.838 kilowatt. So the actual input power will be almost around 20k, although the initial output that we saw was 18, but due to efficiency there is an increase in the power needed to run that motor, so I need more power as an input, which is 20.8, just to be able to run it with efficiency that is equal to 89.5%. For the PE motor, the input power is equal to 18.650 kilowatt divided by 0.93, which is the 93 efficiency, 93%, and that will equal to 20.054 kilowatt. That means it needs less input power, less power to operate. Now we determine the total kilowatt hour per year with 3,120 hours of operations. For the standard motor, we multiply the number of hours of operations per year by the kilowatt input that we calculated before, and that will equal to 65,018 kilowatt hour per year. While for the PE motor, with the same number of operating hours and the 20.054 kilowatt, it will equal to 62,568 kilowatt hour per year. So the number of operating, or the kilowatt hours per year is less for the PE motor than the standard or conventional motor. Calculating the annual cost for each option, or for each motor, at 0.07 kilowatt per hour, we find that the cost for the first one will be $4,000. For the standard one will be $4,551 per year, while the PE motor $4,380 per year. The annual equivalence worth, or capital cost, for each will be calculated through the formula where we have the initial cost, $13,000, and that's the P, or the principal amount. So 13,000 multiplied by A given P with 13% and 20 the number of periods, that will be 1,851, while for the PE motor is $2,221. The total equivalence or equivalent cost for the standard motor with the annual equivalence with 13% will equal to 4,551 plus the 1,851, which will equal to $6,402. While for the PE motor, it will equal, with 13%, it will equal to 4,380 plus 2,221, and that will equal to $6,601. So the cost per kilowatt for the standard is less than the cost of the PE motor. We can use Excel to find the operating hours with both costs are equivalent when we use the goal seek and make them break even or be equal. Then we can see when will these two motors will be equivalent or break even in the cost, the operating cost. Now, what if the options or the alternatives have unequal project lives? And in this case, you can see that we have model A, model B, and for the first model, we have 3 periods, while for the second model, we have 4 periods. And the cash flow is shown in the diagram in this example. So if we go to the first model and start the calculation with knowing that it will be based on cycles, we can calculate the present worth. Calculating the present worth means bringing all these values to 0.0. So we are going to keep the $12,500 at 0.0, then bring the 5,000 to 0.0, then the $5,500 to 0.0, then the 6,000 to 0.0, and then the 2,000, which will be future value, salvage value for that model. Once we bring all these values to the present worth, you can see that the value will equal to $23,637. Using this value as a present worth, we can use the formula to find the annual equivalence with 15% interest, and that will equal to $10,352. With 4 replacement cycles, remember that we did that before, where we had cycles and we calculated for the first cycle and we calculated for all cycles, and we found that the annual equivalence will be the same whether it's for 1 cycle or for 4 cycles. Now let's work on model B. For the second model, or model B, for the first cycle we bring all the values again back to 0. So we have the 15,000, which is at 0. We bring the 4,000 to 0, and we bring the 4,500 to 0. We bring the 5,000 to 0, and then we bring the 4,000 to 0. Now notice that we have n equal to 4, while in the first model we have n equal to 3. Knowing that, we calculate the present worth with 15%, and that will equal to 27,456. Now we use this value as present value to find the equivalence, annual equivalence with 15%, and that will equal to minus $12,024. With 3 replacement cycles for that model, we will find that the value also will be $12,024. Although we will replace the model A 4 times, while we replace the model B 3 times only, we can see that the first model, which is model A, is less cost, and it has, although it has shorter lifespan, it's less cost and will be better choice to go with than model B. So in summary, the present worth analysis and annual equivalent worth analysis are 2 techniques or 2 methods that are used to compare alternatives or assist in making the decision of accepting or rejecting a project. With the capital recovery cost factor, or CR, it's one of the most important application of annual equivalence analysis, which allows managers to calculate an annual equivalence cost of capital for ease of itemization with annual operating costs. In addition, it takes the salvage value into consideration once I use that model. The annual equivalence is recommended over the net present worth analysis in many real-world situations because of these reasons mentioned here. I don't think that I need to read it for you. You can read it yourself. But you see that it assists in the reports, in the unit cost, in the cost per unit of use, and in the decision of buy or make. So all these makes the annual equivalence more recommended or preferred for managers than the net present worth. That will be all for this session. If you have any questions, you can email it to me through Falcon Online. Thank you and have a great day.